All right, welcome to what should be the last video of this unit. We have gone through the kinematic quantities, we've gone through the kinematic equations, and now we are at graphs. So we touched on graphs kind of lightly when we did this unit while we were still in school. But the graphs of the kinematic quantities can be very, very useful, and they all relate to one another. So if you remember, we did an activity where you had to create or match graphs of motion. So I gave you a packet that had a bunch of graphs of motion, and then you had to recreate all of those graphs using your bodies and the motion detectors. So those were position versus time graphs, but we can also see that velocity versus time graphs tell us something interesting too. So first of all, velocity is the slope of a position versus time graph. So if you have a graph that tells you where an object is per unit time, the slope of that graph will indicate the velocity at that time. So if we, this formula for slope, like the standard slope formula, is m equals y2 minus y1 over x2 minus x1. If we put position, which we call x, and this is where it gets a little confusing, but if we put x position on the y-axis and time t on the x-axis, then the slope formula becomes m equals x2 minus x1 over t2 minus t1. So how does this end up being velocity? Well, m being the slope, x2 minus x1 becomes x final minus x initial, t2 minus t1 becomes t final minus t initial, and we know that that is the definition of velocity. So therefore, the slope of a position versus time graph is velocity. Let's look at what that might look like. So here's a position versus time graph. So what this tells you is where the object is at any given time. So if we look at 2 seconds and we go up to that line, we can see that the position is at 10, and this might be in meters, it might be in inches, whatever. At 4 seconds, we can go up, hit the line, and we will see that the object is at position 20. At 6 seconds, the object is at position 30, and so on. So this blue line will tell you where the object is at any particular time. So let's say we want to pull some information out of this graph. One thing that we could pull out of this graph is the velocity of the object at any on this graph. So it is a single solid line that is straight. So we know that it is going to have one slope for the entire graph. So let's go ahead and pick some points here. So I'm going to use this point and I'm going to use this point. So this point is 2, 10, and this point is 6, 30. Let's go ahead and let's calculate the slope here. So we know velocity is change in position over change in time. So our position final is 30 minus our position initial is 10 over our final time 6 minus our initial time 2, giving us 30 minus 10 is 20 over 6 minus 2 is 4, or 5 meters per second. So from this graph, we were able to determine the speed of the object in that interval of time. So the next type of graph that we might see is a velocity versus time graph. So a velocity versus time graph would be a graph in which velocity is graphed on the y-axis and time is graphed on the x-axis. So again, the formula for the slope of a graph is y2 minus y1 over x2 minus x1. So the y-axis becomes velocity v, so the numerator becomes v2 minus v1. And time is graphed on the x, so the bottom of the slope formula is going to be t2 minus t1. So if we do this, same thing that we did last time, v2 minus v1 becomes vf minus vi. T2 minus t1 becomes tf minus ti. So if we have delta v over delta t, we know that's the acceleration, so therefore the slope of a velocity time graph is acceleration. And let's look at how we would determine that. So this graph has velocity on the the y-axis and time on the x-axis. So this particular graph has two distinct sections. We have this section and we have this section. So let's start with the first section. We notice that this segment is flat. So what that means for us is that if we're reading this graph, at 0 seconds, it has 4 meters per second of velocity. At 1 second, it similarly has 4 meters per second. At 2 seconds, it still has 4 meters per second. So if we're maintaining our velocity, we have the same velocity for a full 2 seconds, that means our acceleration is 0. So for this segment right here, I'm going to put that in blue, acceleration is 0 meters per second squared. And that's for this section. All right. Now let's look at this other section. I'm going to circle it in red. All right. This section, we have a downward slope. So the first thing that we could do is we could recognize a downward slope means a negative acceleration. We could also rationalize this by saying, okay, at 2 seconds, I have a velocity of 4 meters per second. At 4 seconds, I have 0. So I have gone from positive velocity to 0 velocity. Therefore, I must have gone in the negative direction. So let's pick some points. This is 2, 4, and this is 4, 0. So let's use the slope formula. So the slope formula is acceleration is delta v over delta t. All right, I'm sorry, the acceleration formula is delta v over delta t. So that means vf minus vi over tf minus ti. So our velocity final is 0 minus our velocity initial of 4 over time final 4 minus time initial 2. And that gives us a negative 4 over 2, or a negative 2 meters per second squared. And that is the acceleration for this segment. All right, that's everything. So you should have, by this time, watched all the videos. There's going to be a series of questions and or handouts that you're going to have to answer and submit for your work. Good luck. Please feel free to email me with any questions. And if you do have a question, you can also jump into the Zoom call every morning from 10:45 to 12:15. And I will be happy to answer any questions you have there. All right. Thanks for watching. Goodbye.